A variety of new techniques invented in the last 4 months have greatly increased the length of tasks that LLMs can tackle, as well as reducing costs by 3 or 4 times with no performance reduction. The best of these is observational memory, which has provided such an advantage to platforms like Mastra that they've been able to use it as a selling point to compete with Claude or OpenAI. Memory management has evolved significantly in the last 3 years. In early 2023, generally if a task took more than the context window of an LLM, you would have to create a new conversation with no context. This massive problem caused a massive uplift of RAG and memory retrieval and saving mechanisms, but all of these led to poor performance and didn't lead to huge benefits. The first viable solutions to not running out of memory really came with compression and summarization techniques. This is where you take all of the conversation's context, plug it into a new LLM to summarize it down to the important bits. This is actually what Claude Code uses to this day, and it's also what a lot of other tools. However, this creates a terrible experience. When you hit the context limit, you have to wait for 30 seconds or a minute for the context to compress, and often it will compress out a lot of very important material. This is where a lot of people have been inspired by the way the brain compresses information to try to build a new wave of compression techniques that don't require you to wait for 30 seconds and don't lose all this critical information. It turns out that 200,000 tokens is actually a lot of information for you to store, so it actually does have enough context if you do the right compression techniques to keep what anyone needs. Observational memory is one of these continuous compression techniques. It's based upon an observation of how human memory works, where events from a long time ago, we only store the small sliver of the most important information. Events a medium amount of time ago, we store a medium amount of context, and extremely recent events, short-term memory, we store a lot of context. This means the total amount of context we use is logarithmically proportional to the amount of time the task took. Because required tokens in the conversation context has gone from linear to logarithmic, we can also just cut how much token usage we have in general. In fact, observational memory generally is used with 1/4 of the standard token usage of without any kind of. According to a lot of benchmarks on longer-term tasks, observational memory and other similar compression techniques lead to very little performance degradation, but do allow much longer tasks to be completed for a much lower cost and with also faster inference due to less tokens being processed. It's also completely compatible with prompt caching because of the way that the compression happens. The mechanisms behind observational memory are actually extremely simple. First of all, main mechanism behind it is we have a long-term memory log. This is where every single important long-term memory is represented as a single line with a basically a summarization of the critical information. Every time the main agent's context reaches a certain threshold, such as 30% of the total context window, a task will be run to compress some of the early messages in the conversation into long-term memory. There's also a second compression threshold. When the long-term memory itself reaches 20% of the total context window, we will run another round of compression where the long-term memory will itself be compressed again. As a user, I can say this feels quite magical. It feels like the conversation goes on and on forever, and it still represents key information. Observational memory is not alone though. There's a variety of good techniques that are simple to implement that are much more effective for all kinds of agentic operations than the status quo. I'd recommend having a look around as it may help you a lot.